Good afternoon, distinguished colleagues and guests. It's March 18th, 2022, 2 p.m. Moscow time. We're beginning the panel session for the defense of the thesis by Iurii Molotkov. The thesis is submitted for the academic degree of candidate of sciences in physics and mathematics. The specialization is 133 theoretical physics. The topic is dynamics investigation of Bose system in the vicinity of lambda-point on the base of microscopic theory in the framework of time-dependent Green's function at finite temperature. Under the order issued by the academic secretary of St. Petersburg State University, Alexander Gneodov, as of December 7, 2021, number 11768/1, I, Nikolai Antonov, Doctor of Sciences in Physics and Mathematics, Senior Researcher, Professor of the Department of High Energy and Elementary Particles Physics of St. Petersburg State University, was appointed the chairman of the board. The order also approved the members of the board, namely Laran Adjemian, Doctor of Sciences in Physics and Mathematics, Professor, Department of Statistical Physics of St. Petersburg State University. He's with us. Sergei Derkachev, Doctor of Sciences in Physics and Mathematics, Senior Researcher at the Lab of Mathematical Problems of Physics of the St. Petersburg Department of the Steklov Institute of Mathematics of the RAS. He's here with us. And Mikhail Gnatich, hello. Doctor of Sciences in Physics and Mathematics, Professor of the Department of Science of the Faculty of Science of the Joseph Shafarik University in Košice, Slovakia. And the following member of the board is working remotely today. That's Dmitry Aristov, Doctor of Sciences in Physics and Mathematics, Professor of the Quantum Mechanics Department of St. Petersburg State University. Dmitry, do you see and hear us? Yes? Yes, I do. Okay, thank you so much. The answer is yes. And let me introduce our candidate for the degree, Iurii Molotkov. And also we have his thesis supervisor, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Statistical Physics of St. Petersburg State University, Professor Nalimov. I would like to inform you that the panel session of the Dissertation Board is being recorded and broadcast on the St. Petersburg State University website and interpreted into English. Currently we have an email address posted on the page with live broadcast of the board session, and all listeners can submit their questions to Mr. Molotkov online. The questions regarding the thesis or the scientific discussion. And thus, our listeners can participate in the scientific discussion. These questions will be forwarded to me by our technical service, and I will read them out during the discussion. The questions must be related to the presentation and the content of the thesis. And do not forget to give your name and position if you submit a question. The questions that have nothing to do with the scientific discussion or dissertation or anonymous questions will not be voiced. Under the order on the procedure of granting academic degrees at St. Petersburg State University, approved by local regulatory acts, hereinafter the order, the session of the Dissertation Board is valid, providing 2/3 of the appointed board members are present, and the total number is not to be fewer than 4 people. The Dissertation Board consists of 5 people, and everyone is here today, including one member of the board who joined us online. We have a multimedia connection with him, therefore we have the quorum. And I kindly ask the member of the Department of Dissertation Board Support to fill out the attendance list. Our session should not last more than 2 hours, and the agenda is as follows. First comes the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements. Chairman's replies to questions, if any. 5 minutes will be given for that. Then, we're going to listen to the candidate's presentation, providing an overview and findings of the research. 15 minutes will be given for that. Followed by questions to the candidate regarding the presentation, 2 minutes per question. Then the candidate's replies to the questions, 5 minutes for all. Then the reports on the thesis. The board members will be taking the floor in turns to provide their reviews and questions. 10 minutes per speaker. Then the chairman's report on the thesis, 10 minutes for that as well. Then the candidate's comments about the reports on the thesis and replies to the questions. Then open discussion. Those willing to submit their positions or make a brief presentation on the topic of the research may take the floor. 10 minutes will be given to everyone. And don't forget to state your full name, academic rank, position, and place of work in the registration list. Then the questions submitted via online. The written questions that will take more than 10 minutes to read out will not be voiced. And I would like to draw your attention to that. Then Article 10, the candidate's replies to the questions, 10 minutes per question. Then a presentation of the candidate's thesis supervisor. Then 5-minute discussion before the open balloting on conferring or non-conferring the academic degree. The discussion of the results of the defense is not broadcast. Then open balloting. We're going to count the votes and record the results in the protocol. Afterwards, we're going to make a decision on whether to confer the academic degree to Iurii or not. And finally, the closing remarks. Distinguished colleagues, any questions or objections? No. Okay. As there are no objections, let us shift to the proceedings. So, the chairman's presentation. A thesis by Iurii Molotkov for the academic degree of Candidate of Sciences in Physics and Mathematics, a specialization 133 Theoretical Physics, is titled Dynamics Investigation of Bose System in the Vicinity of Lambda-Point on the Base of Microscopic Theory in the Framework of Time-Dependent Green's Function at Finite Temperature. The thesis was approved for the defense by the order of the Academic Secretary of St. Petersburg State University, issued November 15, 2021, number 11014/1. Iurii Molotkov has prepared his thesis at St. Petersburg State University as a postgraduate student. And his thesis supervisor is Mikhail Nalimov, and I've already introduced him. 3 published works describe the research findings. They all are published in journals indexed in Web of Science and Scopus. The documents submitted by the applicant, as far as I'm informed, comply with the requirements of St. Petersburg State University and are kept in the certification file of the applicant. And the curator of the defense, the member of the Department of Dissertation Board Support, has all the copies of these documents. And before I give the floor to Iurii, I would like to ask the members of the board, if there are any general questions to the candidate for the degree, is there need to consider the whole list of documents submitted? No. No questions. Okay. Then we're going to give the floor to Iurii. Please, Iurii, you have the floor. Thank you very much for the introduction. As it was already mentioned, I'm going to dwell upon the study of transitions into superliquid state and formalism of temporary functions, grain functions at finite temperature. And as he was already introduced, Mikhail Nalimov is my thesis supervisor. In this work, I'm going to describe continuous phase transitions for dynamic systems. As we know, contemporary systems near the point of phase transition are characterized by critical indices that demonstrate how different thermodynamic values behave when they approach phase transition. And in dynamic systems, above the set of indices, we have the critical dynamic index that is responsible for the time of relaxation. And we know that relaxation time behaves as a traditional length. And here nu is one of the statistical indices, and there were several attempts to combine dynamic critical indexes in systems in which we have superfluidity. And traditionally, for such class of events, we use theories that are based on the basis of Langevin equation. And here, alpha coefficient is Untitled coefficient, and there is some random field with close correlators. And depending on the type of and coefficients of Untitled, we have several models of dynamics. And the shift to superliquid state should be based either on E or F, but we know that a model should change, the F model. And further attempts to combine critical indices Z in this model was faced by difficulties. It was unclear which of the two systems is responsible for this transition, but we also managed to establish the fact of stability for these systems. As a result, we constructed a model that is not based on phenomenological theories, based on Langevin equations. And one of the major objects of quantum field theory is n-point green function. In statistical physics is correlation function, and the equation is given here on the slide. Here you see the green function that is dependent on this combination, that's the growth of statistical operator, and you see n fields that are considered for this event. And these fields are written here in Heisenberg condition, and you see the statistical operator that is chosen for this type of events, and you can construct perturbation theory using green function, using an operator on formalism, here number 4, or formalism with a functional integral. And the time function looks like that. The 4 fields, the operator of behavior has chronological, normal, thermal folds, and here you see the definitions for them. And an interesting question is, how can you act when the time combines? And if we consider the free theory of free gas, and if you conduct research using elementary methods, it turns out that theta functions should be defined as 0, and it means that this function that emerges in these folds equals 0. And in continual integral formalism, it is possible to shift from expression for m and point green functions to Feynman-Kunz, to the functional interval, where in action the integration in time is going across the contour that is known as James-Finner contour. And so interested in the transition to superliquid state, the most simple Hamiltonian that corresponds to the events of such class is represented here in a 12th equation. So you see the representation of density, and in the proximity of phase transition, the details of interactions stop being important due to the congruence And CCS are the standard correlators. And as for the number of propagators in this formalism, is different because here we have 0. And that's the smallest time in the defining of n-point to green functions. And having a Hamiltonian, we can calculate propagators for our system. Here you see them on the slide. The letters here refer to the plot of the contour for the times of propagator. And it's interesting to see here that part of propagators contain oscillating contributions that lead to certain problems in the perturbation theory. The first thing that can be done here is to calculate the first amendment to the green function. And considering this n-point green function and the first correction, we can see that there is a divergence here, and that's a bad divergence, that it introduces a lot of technical problems. And it turns out that this order has another diagram, and this sum is free from this congruence, from this divergence. And that's why you should stick to the necessary margin. And first of all, we should shift to new fields here. So look at formula 14. We get a set of propagators in which T and TF can go to infinity. And if we were interested in the time of relaxation, we're interested in the but here we are interested in the processes that take longer than the time of relaxation. And also from the consideration of connection between infrared and UV divergence in regularized and non-regularized model, it's easy to choose gamma as a dampening indicator. Doing that all, we can see that many propagators changed, and the matrix of propagators responsible for statistical features is separated from other propagators, and it means that thermal propagators do not influence the dynamics of the system and don't influence the critical and dynamic Z-index. Introducing regularization, we can turn this matrix and to get a renormed action. The first thing we do here is we calculate canonical dimensions in order to understand whether we can use standard techniques here. So that's how the table of canonical dimensionalities look like, and it turns out in this case that Tula-Summons interaction is insignificant, and we can leave them behind. So therefore, this renormed action is represented here. And in this table, we see that our model allows us to use standard renorm group technique. So having a renormed action, we can describe the equation system like that. And in a renormed model, we see some equality here, and our theory allows us to consider hypersurface where the charges are equal. And the activities have global calibration symmetry that allows us to choose one of the fields as significantly important. And here we have non-perturbative charge U that was introduced to make the theory renormed. And in the second order, we have several different diagrams different from 0, and the values are given here on this table. Here you see symmetry coefficient. What's the contour term? We can see it here, and having these diagrams, we can describe beta and gamma functions in our model that define the dynamic critical index in beta and gamma functions. And having them, we can describe the system of equations, and thus we can find several fixed points. And as for the stable fixed point, it's the only one, and we divided our charges into parts here, and the only stable point is the point where the significant part is 0, and the imaginary has some other value. And our matrix omega value that is responsible for the stability of the fixed point is in epsilon 1 and is strictly positive, and it means that this fixed point is k-stable. And combined gamma functions demonstrate that in fact that index is equal to what's written in equation 21, and this value fully combines with stochastic dynamics equation. And if we make a replacement, we'll see that our action is model A action. So that's it. In the next order, we have 3 different topologies of diagrams, and the last 2 give us a contribution to beta and gamma functions, because the first topology is actually a combination of diagrams of a lower order. And as for the third order, in perturbations theory, we see the following table. We see a lot of diagrams that were calculated using 2 methods: sector decomposition and analytical method that was developed by Vasiliev in works dedicated to stochastic dynamics. And this considered point has several different values, but the situation is complicated because we were interested in issues of stability in the next order of fixed point. Therefore, we needed to have derivatives of beta function for charge. And that made us consider the products of counter terms in appropriate charges. And here you see the values on the screen. And these are the analytical expressions that we got using the Vasiliev method and calculation method. As I've already mentioned, is sector decomposition. And essentially our diagram is reduced to the expression number 26, where we have just one integral. And sector decomposition method is a classical one. And its algorithms include division into sectors. Every parameter is announced the Q1. Then we have universal Q, and we continue these activities until we see the significant divergence. And if our propagators in the model have a certain structure, exponential structure, it turns out that we can calculate it like that. We can consider the diagram that is defined in formula 29. We can find x for every propagator, then multiplying these propagators that form a loop in this diagram, we get an expression of the exponential structure. And after that, shifting to representation using formulas, we can connect this in line with impulse k. Then if we shift to xt representation, this fold of loop with one line will be quite simple. So that's a simple fold. And basically this calculation gave us the following figures for a mega matrix and for eigenvalues. And if we have a change of sign, we still know that such lines are asymptotic, and we needed to resum them. And here you see the results and the stability in the third order. Such a combination of the critical index made us search for the reason why stochastic dynamics gives us this result, and during the time of classical works, the only superfluidity example was in liquid helium, and according to Landau-Lifshitz, this liquid was not compressed, and based on analysis, you see how we can describe this formula, and we have insignificant contribution to the stochastic equation, and if you just take it away, the dynamic equation loses its superconductivity characteristics, speed and viscosity, and here all the parameters are defined as parameters that consist of combination of density, compressibility, and other physical values. And when we attempt to carry out dimensional analysis, it turned out that most significant analysis is this one in the quadratic part of the action. Therefore, for infrared theory, we need to consider sufficiency or insufficiency, and thus we can describe the model. And this was proved the hypothesis that two-component model A should be considered as a model for transition to superfluidity. So these are the provisions for the defense. That the established theory of time green functions at finite temperature adequately describes the dynamic quantum system at zero temperature. Also, we calculated the dynamic critical index Z for the considered model, and we calculated the matrix in 3 loop approximation. And we also introduced non-zero compressibility for the liquid that reduces F model of stochastic dynamics to model A. I beg your pardon, I announced the first technical break, number 1. At what point? Just now.
Почему ты меня выкинула, сказавши, что свободное время кончилось, я не знаю.
So, unfortunately, I was thrown away.
Видимо, это санкция, я так понимаю, то есть,
Okay, we continue. So it's the break. It's still the break.
Я вас слышал до этого, по какой-то причине меня выкинуло, сказавши, что бесплатное время кончилось. Это, видимо, какая-то спина санкции со стороны Зума.
Так, значит, тогда мы закрываем технический
So,
номер 1 и продолжаем наше заседание.
we continue our session. Yuri, please, you have 2 more minutes. Yes, I already read the provisions for the defense. the introduction of non-zero compressibility of liquid reduces F model in stochastic dynamics to model A. That eliminates issue y critical index Z was equal to the index of model A, and here you see the list of publications that I had, and that's it. Thank you very much. Thank you. The question to the members of the board. Do you have any general questions to the applicant? No questions, but comments. Equation 1 during the presentation. It would be nice to show it in the text of the thesis, because index Z was discussed several times, but it was not mentioned. Yes, I didn't give it in the thesis. Yes. Okay. No other comments? Okay, let us give the floor to the members of the board. I would like to remind you that you can answer the questions at once or after all the reviews are read out, and I offer to answer after every review. Iurii. Yes. Okay, no objections. So, as all the reviews were already published on the St. Petersburg State University website, in order for us to get acquainted with them, I ask you to give just the basic provisions and questions or criticisms. No objections about that? None. Okay. So let us start with Professor Gnatic. Thank you. I'll try to be brief. I won't read it out. And I liked the presentation because I'm dealing with this topic. Everything was clear for me, and I liked that the author made an emphasis on the key points, methodological and technical ones. And you know, this topic is quite relevant because superfluidity system behavior of helium-4 in the proximity of lambda-point is quite interesting, both experimentally and theoretically. And the connections with experimental equipment allows us to study both condensates for the transitions into superfluid state of inert gases, and many aspects of critical or universal scaling behavior were studied, and as experimentally and theoretically, many critical indices can be calculated within the framework of the statistical model, but we also have dynamic aspects as well, most interesting ones, for example, how the system approximates, how it relaxes, and so on. And one of the key characteristics, as it was emphasized here, is index Z. And we've known it for long, and it was classified long before in Halper and Heilenberg review. It's Vasilyev's school, and many of us know this problem quite well. Many are working on this topic for decades, and it was universally recognized that in order to describe the superfluidity, we can use model E, and in the proximity we can use a simplified model E. But still, both models are technically quite complicated. Theoretical processing is quite complicated as well. And the calculations lead to some ambiguity because there are two critical points and it's still unresolved which of them is more correct. And here, as it was already mentioned, they were formed for non-compressed liquid without the impact of hydrodynamic modes. And the people from Vasilyev school are working with turbulence theory, hydrodynamics, and they can approach this problem from a different point of view. They can consider what is the behavior of viscosity that was initially taken out as an infrared and significant parameter. And I've been working with this model myself and have joint articles with the thesis supervisor. We worked with E and F model. We studied the impact of these hydrodynamic modes, including the turbulent one on phase transition. And we made a conclusion that the situation is really quite harsh, and E and F models still remain very complex to describe superfluidity. And maybe in the future we'll manage to calculate something there when analytical opportunities will scale up, as well as numerical methods of calculation for Feynman diagrams. But still, the group of Professor Nalimov started to consider this issue from a different point. They wanted to find a simpler model, and they started studying it from the point of view of microscopics, using a non-trivial set of temporary green functions at a finite temperature. They achieved good results, I believe, and the major steps were represented here. And they gave us a kind of model, non-trivial model. And when they started to calculate all these dynamic aspects, first of all, they saw that it has just one fixed point, and then we'll see what happens next. When they calculated critical Z index, it combined inaccuracy with the accuracy that was calculated with critical index on A model. So that was the main understanding of the problem, and it turned out brilliantly. They calculated in three-loop approximation. They calculated Z in three-loop approximation, and above all, you see, they sorted out the fixed point. First of all, it's 1, and it is still stable. And that is, by the way, very important. This was the first field, and it is one of the key parts of the thesis. And the second field was developed to understand the E and F model. And he decided to consider compressibility. And when you consider it, it influences in a non-trivial manner. I read the review of Professor Antonov here and drew attention to the fact that we need to consider the propagator, not just the classical interaction that allows us to not use infrared index. Therefore, this understanding of this important role of compressibility of longitudinal waves led us to the fact that this model gives us the simplified A model. And that's great, that's brilliant, because if it's so, we'll continue studying. But if it's so, we can consider other things that are of interest. For example, the critical behavior of viscosity, how it subsides. So that's an interesting point. And here I'd like to stop. A physical introduction. And overall, I want to say that all of that is reflected in the work. They had some criticisms to the text of the thesis. First thing being that Overall, the work is written very precisely, and you can't always trace separate steps when you draw conclusions, and that is true for chapter 1. That gives a description of the basic technique for time functions of green, where you describe the substandard substandard divergence. I believe all of these interesting and non-standard theoretical mechanisms could be described in more details, and the thesis is a good platform for such a description. And the second criticism is that I saw a lot of misprints, undeveloped ideas, and problems and formulas. Maybe the small mistakes. I believe you needed to check them all. That's an example. And from the formal point of view, we should understand that when we give articles, submit articles to journals, reviewers, correctors work with these articles, and they work to improve the text of the thesis. And the thesis of a single person has all these drawbacks. Therefore, an important role here is given to the thesis supervisor. I had 12 students, and if something is wrong with the thesis, I believe that's a blame of the thesis supervisor, because you need to read the work and to trace all these mistakes, because that is significant. However, that's the first thing. The second thing is to make it clear. I mentioned the relevance, yes, novelty, of course, and also the results. Results are brilliant if we compare them with other results. And he reported his results and published in very good journals. And high-quality work was submitted where he is a co-author to a physical review, and I'm sure it will be published on this very topic. I believe if you had defense 2 months later, I believe we would see this work here on the slide as well. And another point is that I talked to a thesis supervisor about the contribution, because I know that there are many people that were working on this issue. The thesis supervisor said that decisive work was done by the author. And above all, I work in Dubna and the Joint Institute of Nuclear Research, and he was invited there to make a report in the theoretical physics at the theoretical physics department, and he demonstrated a good presentation. Those who know the workshops of the Department of Theoretical Physics, they understand that it's rather hard to deliver your report there, especially when you have Dmitry Kazakov there. So everything was good. And therefore, considering all of that, I would like to read this important phrase that the above-mentioned criticisms do not compromise the overall high mark that I give to this thesis. And this important remark, the thesis by Iurii Molotkov, titled The Study of Transition into Superfluid State in the Formalism of Green Temporal Functions at Finite Temperature, meets the requirements of the order on the order as of November 19, 2021, on the procedure of granting academic degrees at St. Petersburg State University. And Iurii Molotkov deserves the academic degree of Candidates of Sciences in Physics and Mathematics and Specialization 133, Theoretical Physics. And Articles 9 and 11 of the above-mentioned order are not violated. So that's it. Thank you. Here we had some criticism. Yes, as for the precise character and bad text, I agree with that. certainly. Michael, are you satisfied with the answer? Yes, I am. Yes, he agrees. Then it's okay. Okay. Next. Sergei Derkachev, please. Hello? Well, Professor Gnatich has mentioned what I wanted to mention, but I would like to dwell upon the following fact as well. The central part of the thesis, I won't read my review, but in the second chapter, where the author analyzed a model and carried out standard analysis, and after that he computed index Z. And then there is a kind of intrigue, because the authors detected that index Z combines with an index in model A. So this was an unexpected result, and this result was explained in the next chapter. The models were analyzed, that in K point it combines with model A. So this phenomenon was explained like that. So from my point of view, that's a problem that is well formulated. People found an unexpected thing. They announced to explain it. They did it, and so that's a finished study. And all the calculations in the critical dynamics, they are quite laborious. Therefore, the development of all these methods to calculate diagrams requires a lot of checkups, and in statics all these integrals are calculated using standard methods, but when you switch to dynamics, their integrals should be taken for purity, for impulses, and these calculations are even more complicated than calculations of massive diagrams with massive propagators. Therefore, you know, that's quite a heroic effort undertaken by the author. However, so I can say that I had a very good impression, but on the other hand, I cannot but mention that it's really very brief. My opinion is positive. I didn't give any criticisms, so I decided just to mention them during my review, but they all do not compromise the overall high estimate. But I would like to mention the brief character of this thesis. I like this phrase in the beginning, that's the final blow on the Landau theory was given by the solution of this two-dimensional theory. So this phrase really gives us something to discuss, and I believe they add up a bit to the text from an emotional point of view, and if you sort out everything in details. Certainly I had a lot of negative emotions because, as it was mentioned, index Z is not defined, and for that you need to know what it is, and so on and on. And naturally, you cannot but mention the poor Russian language, all the punctuation marks that are placed in different in the places there where you should not place them. But as that's not a literature work, I believe you can deal with it. And I agree with Mikhail Gnatich that that is the responsibility of Mikhail, as the thesis supervisor, who should have read the text and correct all these mistakes. And finally, I'll read this key phrase. A thesis by Yuri Molotkov, titled The Study of Transition into Superfluid State and Formalism of Green Temporary Time Functions at Finite Temperature meets the requirements of the order. And Mr. Molotkov deserves the academic degree of candidate of sciences in physics and mathematics and specialization in theoretical physics. And Articles 9 and 11 of the above-mentioned order are not violated. Thank you. Thank you. Yuri, you need to answer. Yes, I fully agree. Yes, what else can I say? Sergey, are you satisfied with the answer? I am. Okay, Dmitry, now it's your turn. Yes, I see it here. Already. I'll try to stick to 10 minutes. Well, I understand that on this board I'm the only one with a negative review. And for me that's the first such experience, and it means that sometimes you need to start. And I had no other choice. Sometimes it happens that before the board members start reading, and thesis supervisor reads the thesis somehow in order to understand that everything is okay. And first of all, initially, you need to ask that this. You need to ask the member of the board to participate, and you know, we had some misunderstanding when the author asked me for my passport details, and after that I had a chance to read the thesis, and I was really horrified by the style of writing, and it was already mentioned by my colleagues. Okay, I read the thesis once, then the month before, or rather 2 months before writing my review, I was offered to get acquainted with the text. The author did not contact me, did not offer to somehow get in touch with him if there are any questions that may arise, and that's a rather strange attitude to the defense. Therefore, I decided to read and to read this bad translation from English into Russian, and some of these sentences were mentioned in my review, and in what I liked most is this phrase, hydrodynamics of compressed fluid, of compressed liquid. And a lot of inaccuracies in the documentation of equations, additional parentheses, additional indexes, or maybe the equations lack something, that as a rule. And I did not don't even mention the commas. But then there was yet another thing. The author misunderstands what he's writing about. That's what the impression that I had in the introduction of the operator is associated with a strange thing. So you make two values congruent without positioning of the operator, and after that there are a lot of other exotic ideas that operator of evolution is different from the single operator with the absence of interaction. So this never happens. And such things, you know, I found 6 of them. Cotangent is divided in from x equals x. That's not 1 divided by x, but x. So these are simple arithmetics that really made me question the qualification of the author. And there are numerous of such things there. just 6 of them can be given straight away. So I had impression that he writes about things that he knows nothing about. So I opened up original articles, and they are quite good. Everything is ideal in the articles, and it means that articles were written by some people, and then they were translated by the candidate for the degree and rewritten equations with mistakes. And this really made me question this Article 9. And I doubt that he took an active part in the preparation of this work. Thus, judging by the results of all this consideration, unfortunately, I made a strange conclusion, and I face a strange choice. Either I write that everything is okay with me, based on the fact that he's a good person and I understand it, or I say that he was quite negligent about the thesis, because the thesis does not meet the requirements. It is not well thought of, and the author demonstrated that he can't conduct future academic work if he deals this process so badly. So that is why I say that maybe Article 9 of the above-mentioned order is violated on the active participation of the author. Therefore, I believe that the thesis does not correspond to the requirements of the order, and I believe that Mr. Molotkov does not deserve the academic degree of cognitive sciences in physics and mathematics and specialization in theoretical physics. And my signature is there as well. Thank you. Thank you, Dmitry. Yuri, you need to answer. Yes. As for the style and everything of that, certainly I need to agree with that. And as for the critical comments, certainly I changed the operators and exponents there. I mistaken them, and as for the operator of evolution, in the operator of evolution, in the central part, I omitted the sign minus, and that led to the problems. Well, there are a lot of technical criticisms that you've written about, and I can answer them if you want to listen to that. Well, my position is as follows. Yes. I don't need to hear about these corrections, but I believe that you should have mobilized at a certain point and at a certain time if you want to continue doing science, and I believe that's a serious sign for you, and I hope that you will bear that in mind. Yes, I will. Yes. Okay, thank you. Dmitry answered, said what he wanted to. Yes, okay. Next, Professor Jiman. Well, first of all, I would like to say that the relevance is quite obvious for the work. The technical methods are also interesting, and overall, I would like to say that I had a positive impression of this work, though I agree with what Dmitry said, certainly. When I read this work, I was really irritated by this attitude to the opponents, because checking commas of a graphic mistake is really quite simple, even giving this text to automatic editing program. And certainly we may say that that's not a Nobel Prize for Literature thesis, but anyway, I would not let this article to be published if I got one for review. If the person does not check the text, Where is the guarantee that he does not treat his calculations like that? Therefore, certainly I would not trust the calculations as well. And in this case, only the presence of the opinion of the thesis supervisor and co-authors that are quite reliable allow me to think that these results are credible. And I wanted to see the calculation method in the thesis. Calculation method alternative to sectoral decomposition that was titled as Vasiliev method here. There's Antonov and Vasiliev article. But unfortunately there was no information about it in the thesis. And you get a sector deposition method. And this is explained partially with the fact that the thesis is really short. And you could have well added up this part in the theory chapter, because it would be interesting for me to read about that. And as for a model that is developed from F and E models, technically it's carried out with means that resemble the Vasiliev thoughts about H model. But basically, here it would be nice to have some physical arguments, because you write formulas, and other formulas, and still you should have given some description for them, because there are different fields of frequencies that are of interest in this work, omega taken to the order of k squared, and there are omega to the order taken to the order of k, that's sound waves. And if you take the first field, then sound modes can be seen as high frequency and quick processes, and therefore all the physical objects of propagators that meet the requirements, they become single time. And we know that in hydrodynamics there are diffusion modes, slow ones, and sound modes, the ones that are of higher frequency. In the presence of sound, this is the fact that pressure levels up in no time compared to relaxation of diffusion modes. And indeed, all of that can be seen in the formulas. But it's all quite formalized, and I don't know. I think that those who know how H models are done, it's okay. But as for people who are not involved in these studies, I'm not sure that they are quite in raptures about this work without minimal theoretical background for the work. And there's yet another question: the impact of sound modes that eliminated all other modes except for one. And that's, by the way, a bit curious, because in hydrodynamics we have non-trivial modes, and sound modes don't have an impact on them. For example, entropy relaxation, unit of mass, so they are not covered by sound modes. Okay, but there are models with a low heat conductivity. If you use compression there, maybe it is reduced to a model or not. What happens there? Because as consideration demonstrates that all modes except for one were declared quick. Propagators stopped depending on like delta function in time or derivative of delta function on time. But that is not a reproach to the author, because that's rather a wish for the future. Overall, I believe that the general conclusion is positive, softer than the one of Dmitry, though I was really shocked by all these commas with calculations with 2s and other horrible orthographic mistakes, and some phrases. It was really hard to understand some phrases because that was a bad translation from English into Russian. And I gave these examples in my review. But overall, I will vote for the award of the degree. Okay. Okay, there were criticisms voiced. Yes, as for the style, it was mentioned a lot, and I cannot dispute that. And as for the consideration of slow thermal conductivity model, that's C model, right now we didn't make any attempts to reduce it to some other models because we were interested for the Z index for superfluidity, but it would be interesting to consider it, yes. So, Professor Ajman, are you satisfied with the answer? Yes. Okay, now my review. So a lot was mentioned already on the relevance and on the content of this work, and a lot of criticisms were mentioned, therefore I won't dwell upon commas. I decided not to add them up to my review, because though for some reason they are in wrong places all the time. That's quite a regularity. And if we talk about the content of the work, this field is quite of interest to me because being based on microscopy, quantum models, people systemically construct the models that are phenomenological, based on symmetry, based on the degrees of freedom that are significant, and so on. So this approach overall is quite interesting. The second point is the unexpected result. Quite a challenging one, so to say, because for many years there were disputes about which of the two models describe the superfluidity transition condition, and now based on this serious equipment, instead it turns out that that's still model A, for which we know this Z critical index, and it proves to be more adequate. That's a fascinating result indeed, and it looks quite reliable. And there is an explanation given for that, how F and A models interact and how can they be reduced, how their critical behavior can be reduced to model A. So these results are of interest. They have good good field for future development, and I would like to say that it would be hard to write ideally about all of that, because simultaneously there are several mathematical formalisms that are found in this work. We have operator technique, operator language, we have functional language, we have stochastic differential equations here. We have something that I call a variant of infrared perturbation theory, and there is a Renom group. And there are calculations as well. And I was surprised that this sector decomposition was described in details, and another method is described as a better one, the one that was found in diploma works. Well, that's a complex work. Certainly it should have been described in more details, but this does not compromise the content. It's interesting, it's promising, and I hope that Iurii will bear in mind all the criticisms that he heard today and will continue doing science. And my conclusion is as follows, that I have no significant criticisms. And finally, I believe that the thesis meets the requirements and the author deserves their academic degree with all the references to these Articles 9 and 11. So that's it, what I wanted to say. Basically, you already answered all of these criticisms, therefore I don't expect any comments about that. So, we heard all the reviews of the members of the board, and now the general question to everyone. Are you satisfied with the answers of Iurii at this stage? Okay, let's believe it so. Okay, do we have anyone in the room who is not the member of the board and who wants to comment on this work? None. Okay. Did we get any external reviews? No. Okay. Well then, now I'd like to give the floor to the thesis supervisor. Mikhail, tell us about the author. Well, as it was already mentioned about science, I'll just say that the use of several different approaches for one thing. So this is explained by the fact that we contradict to classics and the general idea. As for the criticisms to my work, I accept them. You know, I never read the thesis of my PhD students, and Alexander did not read mine as well. And not only mine, he didn't like to read PhD thesis. But maybe you should, though it's hard for me to do that. And if I know what we're talking about, I just flick through the pages, paying no attention to the misprints. Though the thesis was written in times when the contacts were stopped, this pandemic, left us with just several Skype contacts and so on. But the main thing that I wanted to say is how Iurii worked. The calculations of these diagrams. He was the main researcher in calculations. And if these diagrams of the first part, 1 and 2 loop, we calculated them together, well, you can't do it separately because otherwise you'll just lie somewhere. You always need control here. We calculated them together up until we had our results were the same. And as for the more complex diagrams, they were calculated together with a student, Trinogin, and he guided the student during his last year in PhD course. The student defended his bachelor thesis, and Iurii included his results into this work. Therefore, as an academic worker, he can guide students, he can independently, well, not formulate the goals, but still provide decisions for the goals that were formulated. He's capable of doing that. As for the articles, these articles started with his ideas. After that, we corrected them, shortened them, placed parentheses everywhere, removed the text, especially if they are in the English. And so As for the discussion of those results, Iurii always participated in all of these discussions, and that's it. That's what I wanted to say. Okay, thank you. Anyone else willing to comment somehow? Add up something? Yes, may I? Well, I wanted to say that the thesis supervisor explained some of these problems that I mentioned, so I'm satisfied. And he emphasized that for the recent 2 years, you had limited communication. That's an interesting factor that we didn't bear in mind. Certainly, we should consider that as well. Yes, thank you very much, Mikhail. You explained the situation indeed. The only thing is that's a question to the author, or rather a wish for the author. You have good potential. Please pay attention to documentation details, because that's what's most painful in your work, and it really is a hindrance, a serious hindrance. Okay, thank you. I have a remark as well. Today I was surprised by the fact that Iurii spoke without jargonism. We have this problem as well. Today he didn't use them, at least. Yes, that's a significant progress for him. Okay. If that is it, if no one else wants to add up anything, then we stop taking questions. And before we draw conclusions and before we vote, I would like to ask the members of the board and the candidate for the degree if there are some remarks or questions on the procedure of our session, maybe the ones associated with remote access regime. I have none. None. No. No questions or remarks. Thank you. Okay. Next item on our agenda, the vote. And before the vote, there's an interesting question. Distinguished colleagues, before the open balloting, we have an opportunity to announce a technical break to discuss the results of the vote, switching off the sound of the broadcast, and asking everyone to leave. How do you think, do we need such a closed discussion to discuss the results? Or we can proceed straight away and take a decision based on the discussion we already had. Can we organize it openly? No. Well, we will vote openly, but we can discuss everything in a closed manner right now. Well, I've given my opinion already. For me, there's no need to organize this closed discussion. Okay? Laurent? No? Dmitry, what about you? I believe no need for that. Okay, I believe everyone made the final decision. Okay, we'll continue then. And now we switch to the vote. So everyone is going to voice his opinion publicly. Now it's 20 minutes past 3. Moscow time. Just in case, I'd like to check, Dmitry, if you hear and see us. Yes, okay. So, I raise a question on the award of the academic degree of candidate of sciences in physics and mathematics and specialization theoretical physics to Iurii Molotkov. There are three options when you vote for, against, and this work, or you abstain from the vote and voted for the award of the academic degree. Each member agrees that Article 11 of the order is not violated by the candidate. Therefore, I would like to quote it. In the thesis, the applicant for an academic degree is obliged to cite the author and or the source of the materials or individual results borrowed, using the results obtained by the applicant personally and or in co-authorship. The applicant for the degree is obliged to note this circumstance in the thesis. And let me also remind you that the decision of the Dissertation Board on conferring the academic degree is positive, provided more than 50% of the board members, but not fewer than 3 people, voted in favor. That's in conformity with Section 17 of the Order on the Procedure of Granting Academic Degrees at St. Petersburg State University. And now, let's vote. Professor Algerman, I vote for the award of the academic degree. Okay, thank you. Professor Derkachov, I also vote for the award of degree. Professor Gnatich, I also vote for the award of the academic degree. Okay, Professor Aristov.
В письменном отзыве я был против, то есть после заседания я не могу полностью отказаться от этой идеи, поэтому я воздержусь.
So I will abstain from the vote. Okay. And the head of the department, head of the board, that's me, I vote for the award of degree. Thus, distinguished colleagues, out of the 5 members of the board, 4 voted for the award of the academic degree. No one voted against it, and 1 person abstained from the vote. Thus, the decision to award the academic degree of candidate of sciences in physics and mathematics and specialization in theoretical physics to Yuri Molotkov is taken. So, Yuri, please, you have the floor for the finalizing remarks. Yes, I would like to thank all the members of the board who are present here today. I would like to thank all my teachers at the Faculty of Law, and I would like to thank my thesis supervisor for all these many years of cooperation and for his advice when I was a master and PhD student. Thank you. Thank you, and let us congratulate Yuri. So I therefore close our session, and I would like to thank everyone for participating, and please switch off the broadcast.